circles more, and some other terms that you haven't seen before with circles. Now, hopefully, a lot of the thing, well, like half the things we're going to look at, hopefully, is review of different terms with circles, but there are going to be some things that I know for sure that you have not seen before. So you will probably want to write a couple things down and make sure that we are locked in. Learning targets. Also, this new slides template that we have, it's supposed to be fun and circles and stuff, and it takes everything in me not to freak out that like these are sideways, and that's just the way that they have it. So don't think that I've went crazy and like can't see straight. That's the way the template is, and I might need to change it because it might really annoy me, but we'll see. Anyway, our learning targets. Students will be able to identify special segments in lines. So you already know some of the things that they would consider special segments, but we're going to look at a few more. Students will be able to identify common tangents. Now, we've seen this word tangent. What does tangent mean?
Side over adjacent.
Opposite over adjacent, right? Now, that was our tangent, like when it comes to a trig ratio. We're going to look at another way that we talk about the word tangent that really does not have anything to do with our trig ratio. Yeah. Order of operations. Okay, so our first term, and just to get everyone on the same page, I know you all know what a circle is, but technically when you talk about like a geometric circle, a circle is a set of all points in a plane. So a circle is not like a curved line, technically. A circle is an infinite number of points that all form that shape. Do you guys see the difference in that? I mean, it really doesn't make a huge difference, but when we talk about the technical definition of a circle is a set of a bunch of points all put together that are the same distance from the center point. Okay, and that's going to become important when we talk about a tangent line and some things later, that a circle is not just a curved line. It is an infinite amount of points that all center around the same point. Okay, and the way that we denote or write a circle, I mean, as you can see, it's a little circle with the center point and whatever the name of that point is. So circle P. Questions so far? Okay. Now, some terminology when it comes to a circle. What things, I list 4 different terms here, but there are more terms on these pictures. Which ones do you already know? Call one out. Diameter, right? And that's the distance all the way across from one side to the other. Radius, from the center to one of the sides. Circle, good. I don't see that on there, but good job. What else do we know? Chord. That's okay, Cole. Now we all know chord. It connects 2 different points on the circle. It does not go through the center. We know the word center. So we pretty much covered most of these. Now over here in the second image, that's where things probably get a little bit more like, what the heck, right? That's probably what you were thinking. Secant, we have not seen. Point of tangent, we have not seen. So let's talk about those. First, Cole, here's a chord. A segment whose endpoints are on a circle. So remember, the diameter has to go through the center. That's what separates a diameter from a chord. But a chord can just be any 2 points on the circle, or have any 2 endpoints. Now, a secant, like it says, a line that intersects a circle in 2 points. So a chord is a segment, right? The secant is a full line that keeps on going. So chord and secant, very similar, just a secant is a line. Now a tangent. A line in the plane, so don't get too caught up with the whole plane thing. A line in the plane of a circle that intersects the circle in exactly one point. And you might be thinking, how can a line intersect a circle at exactly one point? Well, what do we talk about the definition of a circle being? What is technically the definition of a circle that we talk about?
A perfectly round thing.
Well, perfectly round, yeah, but it's an infinite amount of points that all center around one point, right? So when we talk about a tangent line, to say that the tangent is a line that intersects the circle in exactly one point, that makes a little bit more sense. Now my drawing isn't great. You can see it a little bit more here, but you can see how at just the right angle, it's possible that this tangent line intersects the circle at just one point. So that is our definition of a tangent. Now, for this week, I mean, you have to remember it again for the exam, but for this week, when we hear tangent, we don't need to think opposite over adjacent. Now, point of tangency. This probably is not a very big surprise, but that is where the tangent line intersects the circle. Like this diagram actually is pretty good. So if I were you, I would probably sketch that diagram and maybe not even worry about writing these sentences. But you can if you want to. But the point of tangency is where that tangent line and the circle intersect, or where they meet. Questions about any of those? And that covers the first little bit of that big ideas assignment, right? That was a math, maybe not matching, but you had to give the terms and give like what line, what circle, what point match certain terms. Like I said, I don't think there's any, nope. All I'm doing is giving you terms here. I'm not even showing examples, and then I will let you work, because the big ideas assignment is about 20 questions. So I want to give you time to get that done in class. I can look for a second if it's related and helps everybody.
How do you do this?
Well, we shouldn't be working on a big ideas assignment right now. We should only have the slides up. So we'll talk about that eventually. Yeah.
It's the one that says like, tell how many common tangents the circles have. Yeah. Yeah, you gotta use that. You have to use it.
He just said
Yes.
I thought he said we were supposed to be working.
No. Jack, you're so nice. That's why I can't get mad at you, because I know you don't do it on purpose. But I did just say yes. Only have the slides up, but we can look at that after, okay? No, that's all right. And like I said, that's why I can't be mad at you, because you don't do that on purpose. Now, if it was Alton, I would lose my mind. But it's all good, Jack. That's not equal? That's all right. If it was Will, I would lose my mind too. What do you got to say about that, Will? Oh. Okay, that actually was pretty funny. Good one. Okay, anyway. Now, let's look at a couple more terms. So, we not only can have like a tangent line on a circle. Stay with me. We can not only have a tangent line on a circle, we also, like this term says, can have a tangent circle, where both of these circles, I think this is a little better example, but this is all right too, where both of these circles intersect at just one point. Okay? So, well, we'll start there. Yep. And we can have that circle, like you can see, be inside the other one and they intersect at one point, or they can both be external and intersect at one point. So we would consider those circles in both situations to be tangent circles. Now, concentric circles. Like it says, they're circles that have a common center. So, do these two circles have a common center right here? No, they do not. So they would not be concentric. But like in this example, they both have the same center point. So we would consider those concentric circles. I mean, you could have a ton of concentric circles that would just keep moving out and out and out. Like think about it like a ripple in a pond. Like if you drop a rock and it ripples out, right? Those would all be, in a sense, concentric circles around where you drop that rock in. Last term, then we have a theorem to look at. A common tangent. A tangent line or segment that is tangent to two coplanar circles. So, like you can see with both of these lines, they're not just tangent to one circle. They are tangent to two circles. And not only do we have one line that is tangent to both circles, but there are two different lines that are tangent to both circles. So that's something that will come up in your assignment. It'll say draw in or write in the tangent lines of these circles, and you'll have to look, and it should kind of help you snap it right into place, but help you see what the tangent lines are. So we would say these two circles have two common tangents. Questions on those three terms? Okay. Last two theorems. And I want you to read these, each of these for a second. I mean, this right here is 10.1, 10.2. That I want you to take just a second to draw a picture of what you think like the textbook would have as a picture for each of those theorems, or try to draw what those are representing. And then I'm going to let somebody, well, two different people, draw their picture on the iPad. So take a second, read them, try to understand what's going on from things we've learned so far. See if you can draw a picture that represents what that is talking about, or a diagram that would be helpful in understanding the theorems. Work on your critical reading skills. Sounds good. Good circles so far. That's a good start. No, you cannot do that. No, you have to think for yourself. No using Google.
No, this was Bing.
No using Bing. That's even worse. Who uses Bing?
Better than Google.
Is it?
Especially on an iPad.
Especially on these things.
It doesn't block it.
You can actually look at the images. Like, I think there's like, there's a new one.
You cheater, draw your picture. You're poisoning everybody's mind.
Yeah, I think I'm right.
You got a picture?
Yeah. I'll be
Well, which one did you draw your picture on?
I might be able to place
No. Then someone else needs to draw a picture. Someone else needs to draw their picture. Draw small.
I can't erase it.
What do you mean you
I
can't
got
erase
it on the Sunday, played like 2 games, I'm gonna get stabbed.
No, draw it in its normal size right there. Do not listen to Cole. And I need somebody to draw the second one.
You should leave the open
You're bad at
I know.
That's just how
Who wants the second one? Who wants to draw the second here?
that one's so easy.
That's all right. We know what you mean. There we go. That's good. Who wants to draw the second one? Jack, you got the second one? Good job. No! What are you doing? Someone needs to draw the second one. Come on, who's got the second one? Tangent segments. So at least two tangents from a common external point are congruent. Somebody can draw a picture. Ask Braden Let's think about it. Tangent segments. So we just learned about circles. And we learned about what a tangent segment is. Stay with me, it's our last thing. Well, I had to. Hey, Braden. Literally, I'm trying to get through like 3 slides, and a bunch of people are talking. Tangent segments from a common external point are congruent. So if we look, well, sorry. I don't want to steal the show from Ethan. First, let's talk about our first theorem. Okay, tangent line to a circle. In a plane, a line is tangent to the circle if and only if the line is perpendicular to its radius. So I think what Ethan was trying to show here is that we had a tangent line, right? He even drew an extra one in for no reason, just for visual effect, which was nice. Oh, in the plane. Oh, you're thinking like coordinate plane. Okay. That's good thinking. It's not technically, I see where you're coming from. That's not exactly what needs to be there, but that's next level. We'll get to the coordinate plane in 10.7. Tangent to a circle, if and only if the line is perpendicular to its radius. So Ethan drew in the radius to the tangent point and showed that is 90 degrees. Very good. So the only way we can know that something is a tangent line is if the radius is perpendicular. Now, with the second theorem, we have our circle. We have 2 segments that are tangent to this circle. Now, like we said, this point of tangency is just a point on the line and a point on a circle. Now, these 2 tangent segments both intersect at the same external point. Now, what that means is that these 2 segments from, we'll say AB, is congruent to BC. So those 2 segments are the same. If we have 2 tangent segments that meet at an external point, then those 2 segments are the same or congruent. What questions do you guys have? I know I didn't give any examples or go through practice or things like that, but I want to get the terms in front of you. You have a decent size assignment. If you have questions on the big ideas, I'd be happy to do one on one of the slides here so we can hang on to them. But otherwise, I'll let you work for the last 30 minutes. Okay? Ready, set, go.